Earth, our home, the jewel in space, and all that we know is on it. But do we really know what is beyond it? Let us explore where it all began, where it is and where it is going to go, from the ends of a universe to the depths of a sea. Welcome to Eylof's channel, where we will explore the universe and all that's in it together. In the beginning, there was nothing. It was a nothing so profound it defies human comprehension. We may think of the emptiest parts of a universe today, between the realms of distant galaxies, as nothing regions. But even they contain a sparkling of atoms, and a faint radiation of dim shafts of light passing through. More fundamentally, the empty regions today are supported by invisible structure of space and respond to the inaudible clock of time. A long time ago there was no matter, no radiation. More importantly, space did not exist. Time did not flow. Our journey begins once upon a time when there was no space and there was no time. There was nothing, no stars, no constellations, no planets, no you. We cannot say what was before this, as our minds cannot comprehend how nothing looks like. You all have heard about the Big Bang theory. No, not the sitcom, but the start of everything as we know it, and or do not know today. The Big Bang was not, as the name says, an explosion in space, but rather an appearance of space in the universe. The universe was born as a very hot, dense single point in space. Scientists can put together a picture, so to say, of the early universe by observing cosmic microwave background. It is the afterglow of light and radiation left from the Big Bang. See it as a window through the past of a real lifetime time machine. But looking at the stars now, the light that you see at this very moment is millions of years old. The universe is so big that it takes a very long time to get from the source to what you see. So when you look up at the stars, you're technically looking into history, into the past. When the universe was extremely young, like just started, I'm not even going to try and explain how much of a second that is. The universe went through a sudden and rapid growth spurt. This was known as the inflation. The universe in that brief time, hundreds of a billions of a trillions of a trillionth of a second, grew exponentially and doubled in size with at least 1,000 plus times. After the inflation, the universe started to slow down, but still growing. The space expanded and the universe started to cool down, which formed matter. Light chemical elements were created in the first 3 minutes of a universe formation. As the universe cooled down, protons and neutrons collided to make deuterium, which is an isotope of hydrogen. Much of this deuterium combined to make helium. For the first 400,000 years after the Big Bang, the intense heat of a universe creation made it too hot for light to shine. Atoms in the universe crashed together with enough force to break up into a dense opaque plasma of protons, neutrons and electrons that scattered light like fog. Matter cooled enough after the first 400,000 years for electrons to combine with a nuclei to form neutral atoms. It is known as the recombination. The absorption of free electrons caused the universe to become transparent. The light that was unleashed at the time of now detectable today in form of radiation from a cosmic microwave background. About 400 million years after the Big Bang, the universe started to come out of its so-called dark age. The period is known as the Age of Reionization. During this time, clumps of gas collapsed enough to form the very first stars and galaxies. Ultraviolet light from these energetic events cleared out and destroyed most of the surrounding neutral hydrogen gas. The process of reionization plus the clearing of foggy hydrogen gas caused the universe to become transparent to ultraviolet light for the first time. These days, astronomers search through the universe for the furthest and oldest galaxies to help them understand the early universe. Astronomers can work backwards to piece together the events that became before. Our solar system that we live in today is estimated to have been born after 9 billion years after the Big Bang. That makes our solar system about 4.6 billion years old. Our sun that makes life on Earth possible is estimated about 1 of 100 billion stars in our Milky Way galaxy. And it is about 25,000 light years away from the center galactic core. If you want to know how far 25,000 light years is, I will show you the mathematics in the description below. Theory has it that the Sun and the rest of our solar system was formed from a giant rotating cloud of gas and dust, known as a solar nebula. As gravity caused the nebula to collapse, it spun faster and flattened into a disk. During this phase, most material was pulled toward the center to form the Sun. About the 1970s, the astronomers started thinking that there might be more mass in the universe than what was visible. Vera Rubin, an astronomer, observed the speeds of stars at various locations in galaxies. Basic Newton physics implies that stars on the outskirts of a galaxy would orbit more slowly than the stars at the center. But Rubin found no difference in the velocities of stars further out. In fact, she found that all stars in the galaxies seem to circle the center at more or less the same speed. This mysterious and invisible mass became known as dark matter, infrared because of the gravitational pull it exerts on a regular matter. One hypothesis states that the mysterious stuff could be formed by exotic particles that don't interact with light on a regular matter, which is why it has been so difficult to detect. Dark matter is thought to make up about 23% of the universe. In comparison, only 4% of the universe is composed of regular matter, which encompasses stars, planets, and people. In the 1920s, an astronomer, Edwin Hubble, made a revolutionary discovery about the universe using a newly constructed telescope. Hubble observed that the universe is not static, but rather expanding. In 1998, the Prolific Space Telescope, named after the famous astronomer, the Hubble Space Telescope, studied a very distant supernovas and found that a long time ago, the universe was expanding more slowly than it is today. This discovery was surprising because long thought that the gravity of matter in the universe would slow its expansion or even cause it to contract. Dark energy is thought to be the strange force that is pulling the cosmos apart at ever-increasing speeds, but it remains undetected and shrouded in mystery. The existence of the elusive energy, which is thought to make up 73% of the universe, is one of the most debated topics in cosmology. A lot has been discovered of our universe and how it is started, but even more questions and mysteries lay unanswered. Dark matter and dark energy remain two of the biggest mysteries, but cosmologists continue to probe the universe in hopes of better understanding how it all began. With scientific knowledge and technology improving faster and faster, we are ever closer than ever before to unlocking the secrets of the universe. Will we ever know everything about our vast universe? Probably not, but who knows? Only time will tell. Thank you for watching Eylof and the Cosmos, Episode 1. Remember, there will be a raffle that I will announce the winner when the new video releases of Eylof and the Stars, which will be our sun and the stars. I will make a little short video explaining how the raffle will work, getting a certificate of a star that you want to name. Thank you for watching, and I'll see you in the next episode.